Hello, this is going to be my exam video for Chapter 5, Biogeographical Regions. I have my questions right here, so yeah, let's get started. So question 1 is, what is a biome? So a biome is a geographical region that is characterized by the climate, the vegetation type, like the land structure, not so much or not at all like the species that are present, such as like animals, plants, that kind of thing. Some examples of biomes would be like desert, tundra, that kind of thing. Question 2, what is a biogeographical region? So a biogeographical region is kind of the opposite, is how I like to think about it. And it's a geographical region that is characterized by the species, like the animals, plants, that kind of species that's present, and then the ecological boundaries that can play a role in this, such as mountains, rivers, oceans, that kind of thing. Question 3, how are the boundaries of biogeographical regions outlined? So basically, scientists collect data on the certain species that are in a geographical region, and they basically collect data on what species are occurring in one location to another location, or just a big location in general. And if there is a clear boundary of where a species is present and is not present, then that would be the boundary line to create like the boundary of a biogeographical region. Like for example, if there is one species in location 1, and then there's this big set of mountains, and the species is not living in the mountains because of the climate, then the mountains would be like the boundary of the biogeographical region, and that would be the differentiation of species in one location and not in another location. Question 4, explain one of the metrics used to quantify species similarities between pair of locations. So one of the metrics used is the Simpson equation, and it's basically the amount of species present in location 1 with the amount of species present in location 2 divided by the amount of species present in location 1. And so it's like S1, 2, and then S1. And, or how it would look would be like S1 space 1 S1 divided by S1. And then that would be like the equation that you would use to see if a species is present in both locations or the difference in either location. I hope that made sense. Question 5, describe the general pattern of species similarities in South America and why these patterns are like that. So basically in South America, on the Pacific coast, there is lower similarity in species, whereas Central South America, there is greater similarity in species. And this is because on the coast, there is a huge mountain range on the Pacific coast. And this is basically the natural ecological boundary that serves as a boundary of the biogeographical regions, because the different species, say there's a species that lives right on the water and it's comfortable in that certain climate, and it can't live in the climate of the cold mountains. So that's why there's low similarity, and they're very designated to their two biomes, basically. And then for the interior, like the Amazon, it's a large area of flat land, and this means that the climates are similar, and this means that there's higher similarity in species because they're able to move throughout the land and they're comfortable in the climate all throughout, and there's greater space for them to travel and to be comfortable in. So that's where there's higher similarities in the interior versus lower similarities on the Pacific coast. Question 6, how is the use of higher taxonomy can influence the boundary of bioregions? So basically, how I like to think about this is you can have the same genus of a species in the same location. Let's say, example, a parrot, and it can be in the same landmass, but maybe these parrots, one species is in one side of the land, and then one species is on the other side of the land, and for whatever ecological reason they aren't able to like cross or like intermix, be in the same landmass together. This would be like the use of the higher taxonomy. Sorry, I'm looking at the questions. I swear. This would be the use of how the higher taxonomy can influence it, because if you were just looking at the genus, it would look like, oh yeah, the parrot is in all of this one chunk of land. But really, if we look closer at the different species, then they can be separated, and then there could be different biogeographical regions based on the two different species. I hope that made sense too. Question 7. How is the use of different taxa or species groups can influence the boundaries of bioregions? So basically, I like to think of Homo sapiens, haplogens, as an example of this. Basically, the different species groups are able to migrate and mix in different ways, and this kind of creates the boundaries and creates why species are in certain locations where they are. If we think of like the different groups of haplogens going all around the world, then that would be an example of the different groups that would influence the different boundary regions. I guess I don't know if necessarily I don't know if Homo sapiens would be the best, because we are technically one species, but it's the idea that the different groups of species migrate and mix in different areas, and then they face certain boundaries which allow them or don't allow them to migrate to different areas, and that is why it would influence the boundaries of bioregions. Question 8. How can climate influence the boundary of bioregions? Basically, climate influences the boundary of bioregions because say, for example, climate change. If the climate is, how would I reword this? Basically, if it's warmer in one location and colder in another location, and a species is only comfortable in the warmth, then they're going to stay in the warmth. And if they can't survive in the cold, then they stay in the warmth because they know they can't survive in the cold. That's one example of how climate can influence boundaries. For example, the South America coastline. Climate change, on the other hand, can influence this because if species are going, due to climate change, species are going more north and deeper in the ocean. And this basically means that the boundaries that we see today could be completely different in the future because the climate is changing and it's forcing these animals and other species to go in different location, which then influences the different boundaries. I hope I'm explaining all this okay. I'm very sorry if I'm not. It's like very similar, all the questions. But yeah, I hope that makes sense. Question 9, how can humans influence the boundaries of bioregions? Humans can influence the boundaries of bioregions in lots of different ways. One of them being like urbanization. We can force them out of certain areas because we have built up these big structures where they can no longer live. That can be one reason of why the boundary would change and why species would be pushed out of a location. And we bring invasive species a lot of the times, and this can kill off some species or bring new species in, and that could change the different boundaries. Agriculture is a big one. Humans influence a lot. Also, humans are influencing climate change, which is a whole other reason why the boundaries can shift. Question 10, why are there so many different maps with different bioregions? Basically, there's no like clear-cut way on what defines a bioregion, and if we look at a bunch of different species of plants, animals, that kind of thing, then there's going to be a whole different set of bioregions for a different group, and that's why they can look so different from map to map. I hope that made sense. That was all 10 questions, and yeah.